In this lesson, we are going to be finding and graphing the reciprocal of a linear function. So you'll notice in number 1, you're given the function f of x equals x minus 3. So when we graph that, we would start at negative 3 and move up 1, right 1, up 1, right 1. So that's the graph you see already given to you. What we're going to do is find the reciprocal graph of this, and then we're going to graph that function. So to find the reciprocal, remember reciprocal is when you flip the top and bottom. So right now this would be x minus 3 over 1. So the reciprocal graph would be 1 over x minus 3. Now you hopefully see why that would be placed in this chapter, because this would be a rational function because we have a variable in our denominator. So to graph that, we're going to go ahead and go to our calculator and punch in that problem. So we go to y equals, and we'll do 1 divided by, and then in parentheses you're going to put x minus 3. And close that parenthesis. So we hit graph. Notice we have a vertical asymptote at y equals 3, or excuse me, x equals 3. Hopefully you would have realized that because look at our problem. What's in our denominator? X minus 3. So that means I have a vertical asymptote there. So if I want to graph that, I'm going to go ahead and put on the same graph as our line. We're going to draw on that dashed line. And then I'm going to go back to my calculator and see if I can see where that horizontal asymptote is. And hopefully we're getting good at recognizing this. I think this one looks like it's at 0, right? So I go to my graph and I'm going to say I have a horizontal asymptote at 0. And from here all you have to do is look at your calculator to plot some points, because you are just sketching. So I go to my table. I notice I can plot 2, negative 1, and 1, negative half. So 2, negative 1. And 1, negative half, which is going to be good enough for me to just sketch this. And then when I go to the other side, I'm going to have to move down here past the 3. So 4, 1, and 5.5. 4, 1, and 5.5. That's basically all we're doing in this lesson. So I want you guys, you'll notice I have your set and interval notation down there. I want you to fill them in for these notes, just to get more practice at that, but I'm not going to go through those. I'll just have my answer key out for these so you can check them tomorrow, so you're not having to listen to those, because we did that in our last video. The second one then, same idea. This is over 1, so to find the reciprocal, we'll say 1 over negative 2x plus 4. So I'm going to go to my, why don't we find this vertical asymptote on our own? I would take negative 2x plus 4 equal to 0. So negative 2x equals negative 4. So x equals 2 is my vertical asymptote. So I'm going to go ahead and draw that in now before I even graph it, because I could have done that in the last one also. And then I'm going to go to my calculator, and I'm going to plug in this original problem. So it's 1 divided by, I'm just going to leave all that because that's the same. And this would be negative 2x plus 4. There we go. And then I hit graph. This one's really short. Look at that. I can see that my vertical asymptote's at 2. And I think it looks like my horizontal asymptote's at 0. So I'm going to go ahead and draw that in. Because remember, ours are at 0 or 1, and that one definitely didn't look like 1. So now when I go to my table, or my calculator again, I'm going to look at that table. And I have 1 negative half I could plot, and, or excuse me, positive half. 1 half and 0 1/4. So 1 half, oops, that's not even half. I got too close. 1 half and 0 1/4, like right there. So you can see how this is a worse one to sketch. Look at that. That's terrible. My thing's off. There we go. Kind of close. It's kind of off too, but we'll let that go. It's a sketch. And then I have 3 negative half and 4 negative 1/4. So 3 negative half. Oh, that's more like a fourth. About right there. And 4 negative fourths. Something like that. That's a really bad sketch, but it would work for your quiz because you're sketching it. So again, you do the domain and range for number 2. Number 3, I think I'm just going to skip because it's a lot like 1 and 2, and I feel comfortable that you guys would know how to do it. So again, if you want to try this one, I'll have my key out tomorrow. You can check it. but we're going to go to 4. The reciprocal for 4, if I put this over 1, would be 1 over 1/2 x minus 1. Now hopefully you notice here that we end up with a fraction within a fraction. So what we need to do is, the denominator is 2, so we're going to multiply both the top and bottom by 2 to get rid of that fraction, so I don't have a fraction within a fraction. So 2 times 1 is 2, 2 times half x would be 1x, and 1 times 2 is 2. So this is what it would become. So over here I could put 2 over x minus 2. So then when I'm looking for my vertical asymptote, I'm going to see that it's at x equals 2. So I'll draw that in. And I don't know anything else unless I plug this into my calculator. So I'm going to go to y equals, and it's okay if I plug in my the way I changed it, because I didn't change the value of it at all. So I would have 2 divided by, and then in parentheses, x minus 2. Close that parenthesis, and then I hit graph. And you see that we have our vertical asymptote at 2, and I think our horizontal looks like it's at 0 again. So I'm going to go ahead and draw that in. There we go. And then I go back to my calculator and I look at that table to find some values I can plot. 0, negative 1, and 1, negative 2. I can definitely plot those. 0, negative 1, and 1, negative 2. There's a little sketch. Looks good. Next one then would be 3, 2, and 4, 1. 3, 2, and 4, 1. You noticing how there's always a point that kind of connects between the linear graph and the rational function? It's interesting to notice, huh? So there you have it. Nothing too complicated, I don't think, for today. Just more practicing the graphing the rational functions. And just so you know, if they ever ask you to find the reciprocal of a graph, you flip the numerator and denominator, and then you'd graph that new function. If you have any questions, make sure you let me know.